Okay, chapter 19 will be about electrochemistry. Electrical chemical processes are what are called oxidation-reduction reactions. There are two ways that these can go. Either the energy can be released by a spontaneous reaction that is converted to electricity, or electrical energy can be input into the oxidation-reduction reaction system to cause non-spontaneous reactions to occur. This is an example of an electrochemical process. We split the reaction into two half reactions. We have the oxidation half reaction, which is the reactant that loses electrons, and we have the reduction half reaction, which is the reactant that gains electrons. So in this case, elemental solid magnesium is oxidizing, it's losing electrons, and oxygen is gaining 4 electrons to become 2 dianionic oxygen atoms. So we have to think about the oxidation states of the various components of our reaction and how they change from reactant to product. And another word that we use for oxidation-reduction reactions is redox reactions. I'll say that a lot. So to balance redox reactions, we are typically first given the unbalanced redox equation, and then we separate them into half equations or half reactions, one for the oxidation part and one for the reduction part. And then we have to balance all mass and all charge. So the second thing that we have to do is think about how many electrons are being gained and lost, and we have to make sure that the electrons on the reactant and product side balance out, and then the stoichiometry of the left side and right side balance out. This is how we balance one of the more simple redox equations. I will go through this very slowly in class. Right? Our electrons on the reactant side and the product side cancel, and then we have our net chemical redox equation. Figuring out redox reactions in acidic or basic solutions, this is a much more complicated problem because we have to add molecules of water and stoichiometric equivalents of protons, or H+, to achieve the balanced equation. If we have the oxidation of Fe2+, iron 2+, to iron 3+, and then we have the reduction of chromium 6+, in a Cr2O7 2- dianion to Cr3+ in an acidic solution. We first write the unbalanced equation for the reaction, and we separate the equation into half reactions. We have the oxidation part, that is losing electrons, and the reduction part, that's gaining electrons. The next thing we do is we balance all of the atoms in the system other than oxygen and hydrogen in the half reactions. So we have 2 chromiums on the reactant side of the reduction reaction, we have to have 2 chromiums on the product side. Then if the reaction is in an acidic solution, we have to add water molecules to balance the oxygen atoms on one side, and then we have to add H+ atoms to balance the hydrogens and oxygens on the other side. Then we need to figure out how the number of electrons are changing between the reactants and products in the half reactions, and add those to both sides. Then we have to get the least common multiple figured out for both half reactions and multiply one of the half reactions to match up with the other one. For the oxidation of iron 2+ to iron 3+, the iron 2+ loses 1 electron. The chromium 6+ on the reactant side of the reduction reaction, those each gain 3 electrons, so we need 6 electrons on the reactant side. So then in order to get 6 electrons for the oxidation half reaction, we need to multiply that whole reaction by 6. And then we add the 2 half reactions together and cancel, balance everything out. Right, so our 6 electrons cancel out, and we get this final redox equation. I will go through this again very slowly in class and teach you lots of tricks to figure these things out. At the end, we can double check our work, making sure the number of all types of atoms and the charges are balanced on both sides. If we have a reaction in basic solution, it's slightly more complicated. We have to add OH- on each side that we have an H+ so that they neutralize each other and form molecules of water that might cancel out from waters that we've already added. I will go through that again slowly in class. In the real world, when we make electrochemical reactions happen, we can use 2 different types of cells. We can use voltaic or electrochemical cells. The first kind, voltaic, or sometimes called galvanic cells, when we connect a way to have the electrons transfer from one half reaction to the other, this will occur spontaneously and generate electricity. So we typically have two half cells which have an electrode immersed in a solution of ions. And we have some more terminology that we have to learn. An anodic and cathodic half cells, so the anode and the cathode. So the anodes are oxidizing or losing electrons, and the cathodes are reducing or gaining electrons. So to compare again, the voltaic cells react spontaneously. An electrolytic cell, however, is non-spontaneous, so we need to power an electrolytic cell from an external source of electricity in order to get the reaction to go.